All right, so we're on the last page of the day 7 notes of area of a kite and rhombus. The last page had exercise number 3 on it, and we're given exercise 3 says we're given kite BOAR with segment BO congruent to segment OA, and then some other given information. The measure of angle ARP is 30 degrees, AR is 24 units, and OP is 9 units. Our goal is to determine the exact area of the kite and the measure of angle OAR to the nearest tenth. All right, so if they tell us that segment BO is congruent to segment OA, that helps us identify which diagonal of the kite is the perpendicular bisector of the other. So in this case, because of the definition of a kite and the fact that segment BO is congruent to OA, then segment RA is congruent to segment RB, which means triangle OAR is congruent to triangle OBR. So that should indicate that segment AP is congruent to segment PB. So OR is the perpendicular bisector of AB. So since now I'm just going to kind of fill in some of the missing information. They told us OP was 9. They told us that AR was 24. And then a huge clue here is the measure of angle ARP is 30 degrees. All right, so if the measure of angle ARP is 30 degrees and the diagonals of the kite are perpendicular to one another, that means that triangle APR is a 30, 60, 90 triangle, and we know the hypotenuse is 24. So when we remember our information about 30, 60, 90 triangles is the hypotenuse is always 2 times bigger than the shorter leg, or shortest leg, shorter leg, which is the shorter leg has to be opposite of 30 degrees. So if the hypotenuse is 24, then the shorter leg must be 12, which means the entire diagonal of AB must be 24 because 12 was half of that entire diagonal. Then we should also know in a 30, 60, 90 triangle that the larger leg, in this case PR, which is across from the 60 degree angle, is root 3 times bigger than the shorter leg. So P to R must be 12 root 3 units long. So now we should be able to get the exact area of BOAR because we have diagonal 1 and we have diagonal 2. So the area of kite BOAR should be equal to 1/2 of diagonal 1, and diagonal 1 is 24 units, multiplied by a diagonal 2, which is the sum of 9 plus 12 root 3. Okay, so now the area, well, 1/2 of 24 is 12, so I'm going to have 12 times 9, which is 108, and I'm also going to have 12 times 12 root 3, which is 144 root 3. So the area of kite BOAR is equal to 108 plus 144 root 3 units squared. Okay. Now we still have to determine the measure of angle OAR, the measure of angle OAR. So we're looking at this entire angle. Part of it is 60, so we need to get that other part to determine the measure of angle OAR. Well, I think that the most efficient way to be able to do that is to recognize that this angle we're looking for, we could call that theta if we will. Theta is an angle in a right triangle. And in that right triangle, I know the opposite side and I know the adjacent side. So I can do the tangent of theta is equal to the opposite side of 9 over the adjacent side of 12. Well, to solve for theta, right, I could take the inverse tangent of both sides. So the inverse tangent of the tangent of theta will leave me with theta, but whatever I do to the left side of the equation, I must do to the right side of the equation. So I'm going to have theta is equal to the inverse tangent of 9 out of 12, which is approximately 36.86-ish. Okay. So the measure of angle OAR is going to be it's going to equal 60 plus theta. So since theta is approximately 36.86, the measure of angle OAR is going to be approximately 60 plus 36.86-ish. We're gonna round to the nearest tenth because the directions told us so. So the measure of angle OAR is approximately 96.9 degrees. The measure of angle OAR is about 96.9 degrees. All right, thanks for checking in.